Hey guys, in this video we'll be looking at urine formation in the nephron. Let's get right to it. So this is a structure of a nephron. This is what a nephron looks like. A nephron is a tiny structure in the kidneys. There are millions of nephrons in the kidney. So let's start with this here. This is the renal artery. The renal artery brings blood to the kidneys. And so when the blood comes to the kidneys, it goes through this blood vessel here, which is known as the afferent arteriole. The afferent arteriole carries blood to this structure here. And this structure is very important. You see a mesh of capillaries here. This mesh of capillaries is known as the glomerulus. And the glomerulus is very important because the glomerulus is part of the filtration membrane. The chalice-like structure here, the one that looks like a cup, is known as Bowman's capsule. Bowman's capsule encapsulates the glomerulus. Now let's look at the first process that happens in urine formation. The first process occurs here at the Bowman's capsule and glomerulus. This is known as ultrafiltration. Ultrafiltration is when the blood inside the glomerulus, remember glomerulus is just a mesh of blood capillaries. So from the glomerulus, the blood is going to seep out. It will be forced out into Bowman's capsule. So all the blood is going to be forced out here. It's going to be filtered out. And the only particles that are not large enough to pass through are the RBC, the red blood cells, as well as the plasma proteins. These particles are too large to be filtered, and therefore they will remain in the blood. But everything else from the blood, that is all the contents of the plasma, everything comes out. And whatever has been filtered is the filtrate. This filtrate has a special name. This is known as the glomerular filtrate. This is what happens after ultrafiltration. So what causes this to happen? How come the blood plasma is forced out of the glomerulus into the Bowman's capsule? This is because the afferent arteriole actually has a larger diameter compared to this arteriole here. The arteriole after the glomerulus has a special name. It is known as the efferent arteriole. Efferent arteriole. So the efferent arteriole has a smaller diameter compared to the afferent arteriole. And because of this, there will be high hydrostatic pressure of the blood inside the glomerulus. The blood in the glomerulus is under high hydrostatic pressure, which forces the plasma out, except for RBC, red blood cells, and plasma proteins. And so, what happens to the glomerular filtrate? The glomerular filtrate will then enter this twisted tubules, as you can see here. So now we are entering the renal tubules. And the part that is twisted here is known as a convoluted tubule. If you look at the structure of the nephron as a whole, you can see that we have two convoluted tubules, twisted tubules. There are two. And so they are named based on their position. The one that we meet first is known as the proximal convoluted tubule. So this here is the proximal convoluted tubule. And the one on the other end, as we go on further, this is the distal convoluted tubule. And the one that you see in the middle here, this loop here, the one that forms a loop at the bottom, this is known as the loop of Henle. And so these three structures, the proximal convoluted tubule, the loop of Henle, and the distal convoluted tubule, are known as the renal tubules. After ultrafiltration takes place, the next process is actually reabsorption. So whatever has gone into the glomerular filtrate, a lot of it is going to be reabsorbed back into the blood. Remember, they are now in the tubules. The glomerular filtrate is now moving through the tubules. So we are moving inside here. So as it moves along the tubules, what's going to happen is substances are going to be absorbed back into the blood. And that is why, as you can see, surrounding the renal tubules, we have capillaries. And so the substances in the glomerular filtrate, which is in the renal tubules, will go back into the blood. First, let's look at the reabsorption in the proximal convoluted tubule. Here what happens is sodium ions go back to the blood by active transport. As sodium is being reabsorbed, at the same time, chloride ions will follow. So we have a reabsorption of sodium ions by active transport, and chloride ions follow passively through passive diffusion. This process that's occurring right here is going to reduce the water potential in the blood capillary, because now the blood capillary has a higher solute concentration. And therefore, what is going to naturally happen is water is going to flow down its concentration gradient. And therefore, water is going to follow by osmosis. These are the three things that are being reabsorbed mainly in the proximal convoluted tubule. However, we have two very important substances that are completely absorbed in the proximal convoluted tubule and should not be in the glomerular filtrate once it passes through the proximal convoluted tubule. And they are glucose and amino acids. Glucose and amino acids are actively transported back into the blood. 100%, all the glucose and all of the amino acids are transferred back into the blood through reabsorption by active transport at the proximal convoluted tubule. If there is glucose in the urine or amino acids in the urine, then something is not right. There shouldn't be anything left in the urine. Once the glomerular filtrate has passed through the proximal convoluted tubules, then it enters the loop of Henle. So now we are entering this region. Glomerular filtrate is going to pass through this region, loop of Henle. At the loop of Henle, again sodium ions are being reabsorbed and water will follow by osmosis. Sodium ions once again are being reabsorbed actively through active transport, and water follows by osmosis. And then once we've passed through the loop of Henle, we are going to enter the distal convoluted tubule. So now the glomerular filtrate is entering this portion. And here what happens is, it is similar to the proximal convoluted tubule. Sodium ions are going to be reabsorbed actively. Chloride ions are going to follow passively. And because of the decreased water potential in the blood capillary, water will follow by osmosis. So we have the same reabsorption here. Once this is done, we are going to enter the final structure of the nephron, and that is this structure over here. And this structure is known as the collecting duct. As you can see, the collecting duct has other openings here as well. So these are all connected to other nephrons. That is to say, many nephrons connect to a single collecting duct. So far we've covered ultrafiltration and reabsorption. However, there is a third process that occurs during the whole time of urine formation, and that is called secretion. Secretion is the opposite of reabsorption. Remember, reabsorption is particles moving from the renal tubules back into the blood. Secretion is the opposite process, where substances move from the blood into the renal tubules. So now we are going to be adding substances into the glomerular filtrate. The process of secretion occurs all throughout the renal tubules and the collecting duct, but it is most prominent here at the distal convoluted tubules. Secretion occurs through two processes, that is either active transport or simple diffusion. So we have secretion of from the blood. What is going to come in is we have urea, we have creatinine. So creatinine is going to go from the blood to the renal tubule. We have a few ions that are going to go in as well from the blood. They are hydrogen ions, potassium ions, and ammonium ions. These are the ions that are secreted out from the blood into the glomerular filtrate. At this point, we also have secretion of drugs and toxic substances out into the glomerular filtrate. So these are going out of the blood into the glomerular filtrate. So by the end of everything, when the glomerular filtrate reaches the collecting duct, this is where the glomerular filtrate is called urine. So now we have formed urine. And so the contents of urine are, of course, we have water, whatever water is left. 99% of the water from the glomerular filtrate is reabsorbed. So the water that's left here is only around 1%. And we have all the waste substances, that is the urea, the creatinine, and the hydrogen ions, and so on, all the waste substances. And then we have sodium chloride, because we have sodium and chloride ions. So we have sodium chloride salt here. We also have uric acid. So again, urine should not contain any glucose, it should not contain any amino acids. Let's do a quick review of the whole process again. So what occurs here is, first we have the blood from the renal artery entering the nephron through the afferent arteriole into a structure known as the glomerulus. The glomerulus is encapsulated by Bowman's capsule. What happens at the glomerulus is, the blood has high hydrostatic pressure because of the difference in diameter of the afferent arteriole and the efferent arteriole. Afferent arteriole has a bigger diameter than the efferent arteriole. This causes blood to be squeezed out of the glomerulus, and therefore all the plasma and its contents are squeezed out as glomerular filtrate into the Bowman's capsule, except for large particles that are the red blood cells and the plasma proteins. Once the glomerular filtrate is formed, it goes through the renal tubules where two processes occur, that is reabsorption as well as secretion. Secretion is mainly at the distal convoluted tubules. So once the contents of the glomerular filtrate are changed as it goes along the tubules, when it finally reaches the collecting duct, it is known as urine. And urine from the collecting duct is going to go into the pelvis of the kidney, which is then transferred to the bladder through the ureter. And when the bladder is full, there's a signal to the brain and urine is excreted out of the body. If you've gained something from this video, guys, please do me a favor and hit that like button. Really does help the channel. Thank you very much for doing that. If you do enjoy videos like this, subscribe, because I'll be producing at least one a week. See you guys in the next video.